Hello students, welcome back to Philobytes. Let's continue with the second part of Symbolic Logic, chapter 8. Now we shall be discussing conditional statements and material implications, biconditionals or material equivalence, logical equivalence, statement forms, argument forms, and arguments. So before we start, let's have a very short recapitulation. We are dealing with truth functional connectives, which means any logical connective, that is conjunction, disjunction, material implication and material equivalence between the components of a truth functionally compound statement. We have already completed conjunction, disjunction, negation, as well as logical punctuation in the first part of this series. A PDF of the solved exercises have been provided in the link given in the previous video. So now let's continue. So what are conditional statements? Where two statements are combined by placing the word if before the first and inserting the word then between them, the resulting compound statement is a conditional statement. It is also called a hypothetical, an implication, or an implicative statement. So it is a hypothetical statement, a compound proposition or statement in the form if P then Q. The antecedent in a conditional statement if then is a component that immediately follows the if, sometimes called the implicans or the protasis. The consequent, that is the word which comes later in a conditional statement, that is if and then statement, is a component that immediately follows the word then. Sometimes it is also known as the implicate or the apodosis. So now let's understand the conditional statements with the help of examples. If there is a thunderstorm, then the flights will be cancelled. Here, there is a thunderstorm is the antecedent and the flights will be cancelled is the consequent. A conditional statement asserts that in any case in which its antecedent is true, its consequent is also true. It does not assert that its antecedent is true, but only that if its antecedent is true, then its consequent is true. It does not assert that its consequent is true, but only that the consequent is true if its antecedent is true. The essential meaning of the conditional statement is the relationship asserted to hold between the antecedent and the consequent in that order. If antecedent is true, only then the consequent is true. Remember this. Now there are four senses in which the connectives if and then can be used. Number one, the logical sense. If cats like liver and Dina is a cat, then Dina likes liver. You see, it is very logical. If cats like liver and if Dina is a cat, then Dina likes liver. So it is very logical. The second meaning or the second sense in which if and then is used is definitional. In this sense, the consequent follows from the very definition of the word. For example, if the figure is a triangle, then it has three sides. You see, the triangle by definition is a figure which is bounded by three sides. So from the very definition it follows. third is the causal. In this sense, there is a causal connection between the antecedent and the consequent. For example, if gold is placed in aqua regia, then gold dissolves. So there is a causal connection between gold and the chemical aqua regia. And finally, the fourth sense is decisional. If you shave your head, then I will change my name. So it is my decision. If you do this, then I'll do that. So it is decisional.
So, what is material implication then? Material implication is a special and the fifth type of conditional or implicative statement. Consider the remark, if Hitler was a military genius, then I am Albert Einstein. It is quite clear that it does not assert the previously mentioned logical, definitional, causal, or decisional implications. The point here is that no real connection between the antecedent and the consequent is suggested by the material implication. It is not the same kind of implication as any of the four mentioned earlier. So, this type of implication, where there is no real connection between the antecedent and consequent, is termed as material implication by the logicians. Why did they give it a special name? Because in order to ascertain that it is not confused with the other four more usual type of implications. Now the material implication symbol is like a line, the one you can see here, and it is called the horseshoe. The material implication symbol, being a truth functional connective, is defined by the following truth table. So P, Q, and then P implies Q. It is only when P is true, that is the antecedent is true and the consequent is false, that is Q is false, it is only in that case P implies Q is false. In all the other cases, it is true. P implies Q is true. So just remember, in the case of implication, material implication, true false is false. In all other cases, it is true. With reference to the material implication, certain exercises are given in the textbook Introduction to Logic by Copi and Cohen. So here is the screenshot of that exercise, which I have solved, most of them I have solved, which you will find in PDF 1, which has been linked in the description box, and you can download it from there. This is a screenshot of the next exercise that I have solved for you. Here you have to symbolize these statements, these simple statements, and symbolization can sometimes be quite tricky. So you can practice it, the symbolization from these exercises. In your examinations, sometimes already symbolized statements are given, the truth value of which you have to determine, and sometimes you have to symbolize the simple statements first and then determine its true or falsity. So it is highly recommended that you learn how to symbolize simple statements before you try to determine with the help of truth tables whether they are true or false. So The answers to these exercises will be, you can find them in PDF 2. Now, even though I have solved the questions in the PDF, you will find them in the PDF. Here are certain tricky ones which I would like to discuss in this video. Number one, if Argentina does not mobilize, then neither will Brazil protest to the UN, nor will Chile call for a meeting of all the Latin American states. So the question is, how are you going to symbolize neither nor? We have learnt about either or in disjunction, but here it is not either or, it is neither and nor. Neither nor is a negation of what? Negation of the disjunction. So negation of the disjunction will be symbolized as if Brazil will protest to the UN is B and Chile will call for a meeting of all Latin American states is C, then collectively you can write not within brackets B will C, or you can also write not B and, that is dot, not S, and the antecedent of the conditional statement, if Argentina does not mobilize, will be not A. So the whole statement will be symbolized as not A implies not within brackets B will C, or not A implies not B and not C. You see, the statement either Fillmore or Harding was the greatest US president. This is a disjunction. Can be contradicted by the statement neither Fillmore nor Harding was the greatest US president. And here they will be symbolized, that is F will P, its negation can be symbolized as either not within brackets F will H, or as not F and not H. Both of them are correct. You can use any one of the symbolizations. The next one is Brazil will protest to the UN if Argentina mobilizes. You see, if is later in the sentence. So we have learned that in conditional statements, if comes before the antecedent and then comes before the consequent. But here we do not find any then, and if is later on. So what to do in such a case? Now, conditional statements can be formulated in a variety of ways. If he has a good lawyer, then he will be acquitted. This is a sentence, conditional statement, which we are easily acquainted with. The word then is sometimes omitted. For example, I can say, if he has a good lawyer, he will be acquitted. Here you have to understand that there is a then before the consequent, even though it is not present in the given sentence. Then again, the antecedent and the consequent can have their order reversed, provided that the if still directly precedes the antecedent. That is, he will be acquitted if he has a good lawyer. He will be acquitted if he has a good lawyer. So, you see, he has a good lawyer is definitely the antecedent. What is the antecedent? Antecedent is the reason from which follows a result, that is, from which follows a consequence. So, if he has a good lawyer, even though it is coming later in the sentence, it is still the antecedent. And if comes before he has a good lawyer. That is, if this word comes before the antecedent, which is he has a good lawyer. So the order is just reversed, but the rule, what is the rule? That the word if must come before the antecedent has not changed, because the antecedent is he has a good lawyer. So in this case also, you can rewrite it, the sentence before you symbolize. If he has a good lawyer, then he will be acquitted. This is the meaning which you should be reading into the given statement, even though their order is reversed. Again, if can be replaced by other words such as in case, provided that, given that, etc., without any change in the meaning. For example, that he has a good lawyer implies that he will be acquitted. So that he has a good lawyer implies that he will be acquitted. Here, the word if is replaced, but the sentence, the conditional statement remains the same, the antecedent remains the same, the consequent remains the same, and hence, in all of the above cases, even though they look different, they are all going to be symbolized as L implies A. And what is L? L is he has a good lawyer. It is symbolized as L, and he will be acquitted. This consequent is symbolized as A. So in all the cases, even though the sentences have their orders reversed, the word if is replaced, okay, the word then is omitted, even then all of these statements will be symbolized as L implies A. Hence, the answer to the given statement, that is, Brazil will protest to the UN if Argentina mobilizes. So it will be symbolized as A implies B, because Argentina mobilizes is the antecedent A, and Brazil will protest to the UN is the consequent B. So it is A implies B. The next one says, Brazil will protest to the UN unless Chile calls for a meeting of all the Latin American states. Now, how do you understand the word unless and how you are going to symbolize it? The word unless can also be used to form the disjunction of two statements. For example, either it rains or the picnic will be held, a disjunction, can be written as unless it rains, the picnic will be held. And the above compound statements will be symbolized as R will P. R, it rains, and P, picnic will be held. Keeping this in mind, the given statement will be symbolized as B will C. So Argentina's mobilizing is a sufficient condition for Brazil to protest to the UN. In order to symbolize this one and also the next example, you have to understand the difference between sufficient condition and necessary condition. For a specified situation, there may be many alternative circumstances, and any of which is sufficient to produce the situation. For example, for a purse to contain more than a rupee, it is sufficient for it to contain 5 25 paisas or 11 10 paisas or 3 50 paisas, and so on. If any one of these circumstances obtain, then the specific situation will be realized. So, to say that a purse contains 5 25 paisa is a sufficient condition for it to contain more than a rupee. That is to say, if a purse contains 5 25 paisa, then we can say that it contains more than a rupee. So here P is a sufficient condition for Q and it is symbolized as P implies Q. So if Argentina's mobilizing is a sufficient condition for Brazil to protest to the UN, then it will be symbolized as A implies B. Next one, Argentina's mobilizing is a necessary condition for Chile to call for a meeting of all Latin American states. The notions of necessary and sufficient conditions provide other formulations of conditional statements. For any specified event, many circumstances are necessary for it to occur. Thus, for a normal car to run, it is necessary that there be fuel in its tank, that its spark plugs be properly adjusted, that its oil pump be working, and so on. So if the event occurs, that is the car runs, every one of the conditions necessary for its occurrence must have been fulfilled. It is not like the case of sufficient condition where any one circumstance is enough. Hence, to say that there is fuel in its tank is a necessary condition for the car to run can equally well be stated as the car runs only if there is fuel in the tank, which is another way of saying if the car runs, then there is fuel in its tank. But it is symbolized as R implies F. So the question here is Argentina's mobilizing is a necessary condition for Chile to call for a meeting of all Latin American states. So Chile calls for a meeting of all Latin American states only if Argentina mobilizes. So this is the way you are going to understand it. Therefore, the given question is symbolized as C implies A. Okay, so now we come to the biconditional. This is also known as material equivalence. Material equivalence is a truth functional connective that asserts that the statements it connects have the same truth value. Two statements that are equivalent in truth value are materially equivalent. The definition will be two statements are materially equivalent when both are true or false. So, true is true, false is true. Only when one of them is true and one of them is false, then the biconditional will be false. And the symbol for the biconditional is a 3-bar sign. It is also known as the tri-bar. You can see in the truth table that when both the P and Q, both the statements are true or both of them are false, then P tri-bar Q is true. If any one of them is true or false, then the biconditional is also false. So here is a screenshot of the 4 truth functional connectives that we have discussed. The truth functional connective and the symbol is dot. The proposition type is known as conjunction and the components of the propositions are known as conjuncts. Example, Carol is mean and Bob sings the blues will be symbolized as C dot B. The truth functional connective or the name of the symbol is V veg. It is a, it is like a small v. The proposition type is known as disjunction. Each of the components are called disjuncts and the example will be Carol is mean or Tyrell is a music lover and it will be symbolized as C well T. The next truth functional connective is if then. It is symbolized as a sideways U, which is called the horseshoe. The proposition type is a conditional, and the name of the components are antecedent and consequent. Example, if Bob sings the blues, then Myrna gets moody, which will be symbolized as B implies M. And the last one, if and only if, which is a tribar. It is the name of the symbol is a tribar. The proposition type is called a biconditional. Each of the components is just called a component. And the example is Mirna gets moody if and only if Bob sings the blues will be symbolized as M tribar B. Not is not a connective. It is a truth functional operator. So it has been omitted here. Now we have spoken about material equivalence. Now let's see what logical equivalence is. The statements Jupiter is larger than the Earth is true. Tokyo is the capital of Japan is also true. So they are materially equivalent. But can they replace one another? No, they cannot. So that is the difference between material equivalence and logical equivalence, because in logical equivalence the components can replace one another wherever they occur. Double negation is an expression of logical equivalence and the negation of that symbol. For example, P is logically equivalent to not P, and the logical equivalence is symbolized as T on top of tribar. So two statements are logically equivalent only when they can't have different truth values. It is not a truth functional connective like a material equivalence. So there are two well-known logical equivalences. They are known as De Morgan's theorem. These two tautologous biconditionals or logical equivalences, they are known as De Morgan's theorems because they were formally stated by the mathematician and logician Augustus De Morgan. The first states that the negation of a disjunction is logically equivalent to the conjunction of the negation of its disjunct. Here it is not within brackets P del Q is logically equivalent to not P and not Q. The second one states that the negation of a conjunction is logically equivalent to the disjunction of the negation of its conjuncts. That is, not within brackets P and Q is logically equivalent to not P, well, not Q. Now let's understand arguments and argument forms. So what is the central task of deductive logic? It is discriminating valid arguments from invalid ones. So validity and invalidity are purely formal characteristics of arguments, which is to say that any two arguments that have exactly the same form are neither both valid or both invalid, regardless of any differences in the subject matter with which they are concerned. So let us try to understand what is an argument form. So any simple statement abbreviated by capital letters can represent an argument. For example, Bacon wrote the plays attributed to Shakespeare is abbreviated as B, and Bacon was a great writer is abbreviated as G. Again, Washington was assassinated as A, and Washington is dead as D. Now let us form the arguments. B implies G, G therefore B. That is, if Bacon wrote the plays attributed to Shakespeare, then Bacon was a great writer. So that is B implies G. Bacon was a great writer. That is G. Therefore, Bacon wrote the plays attributed to Shakespeare. Therefore, B. Similarly, if Washington was assassinated, then Washington is dead. A implies D. Washington is dead. D. Therefore, Washington was assassinated. Therefore, A. In this way, we construct arguments. You can see from the symbolization of the arguments that they have the same type of form. Hence, we shall symbolize the argument forms themselves instead of symbolizing particular arguments with abbreviated capital letters. To achieve such a method, the notion of a variable is introduced. Capital letters are used to symbolize particular simple statements. To avoid confusion, we shall use small lowercase letters from the middle part of the alphabet, that is PQRS, as statement variables. So a statement variable is simply a letter for which a statement may be substituted. Compound statements as well as simple statements may be substituted for statement variables. So how do we define an argument form? Argument form is an array of symbols containing statement variables but no statements. This array of symbols must have a logical structure. And these variables are arranged in such a way that when the statements are consistently substituted for the statement variables, the result is an argument. For definiteness, we shall establish the convention that in any argument form, P will be the first statement variable that occurs in it. And as other variables are introduced, they will be labeled as QRS and so on. So here is a little more clarification about abbreviated statements, argument forms and substitution instances, because these are terms you are going to come across very frequently in your logical exercises. So when the statements B and G are substituted for the statement variables P and Q respectively, the result is the first argument. So we first abbreviated the statements, and B implies G, G therefore B, and again A implies D, D therefore A. So from this we form the argument. The argument form, like I said, we will be using P and Q, R, S, like that, in that order. So the first statement is always, the first variable is always P. So both the above abbreviated statements can be written in the argument form. P implies Q, Q therefore P. And the substitution instances of the above argument form may be any of these. That is, P implies Q, Q therefore P implies Q, R therefore P implies Q, R therefore S, P, Q therefore R. So an argument that results from the substitution of statements for statement variables is an argument form, is called a substitution instance of that argument form. Any substitution instance of an argument form may be said to have that form, and any argument that has a certain form is said to be a substitution instance of that form. For any argument, there are usually several argument forms that have the given argument as a substitution instance. Our next topic is validity and invalidity. So every deductive argument is either valid or invalid. A deductive argument is said to be valid when its premises, if they were all true, will provide conclusive grounds for the truth of its conclusion. An argument form is invalid if and only if it has at least one substitution instance with true premises and a false conclusion. If the specific form of a given argument has any substitution instance whose premises are true and the conclusion is false, then the given argument will be invalid. To test an argument form, we examine all possible substitution instances of it to see if any one of them has true premises and a false conclusion. So when we get an argument, we can use truth table method, and we can examine all the possible substitution instances, and if any one of the rows consists of true premises and a false conclusion, then the argument will be invalid. So here is the screenshot of the next exercise from your textbook, where truth tables are required uh, in order to prove the validity or invalidity of each of the argument forms. You can see these. So refer to PDF number 3 for the answer keys, and the link is given in the description box. So this is the next exercise from your textbook. You can see that in the previous practice exercise, you have been given the argument forms whose validity you have to check. But here the questions are given in the form of statements. So first you have to symbolize the statements, form arguments out of them, and then only you can use truth tables to determine the validity or invalidity of the arguments. And if you find any substitution instance where the premises are true but the conclusion is false, then you can mark the argument as invalid. These exercises have been done for you. Please refer to PDF 4 for the answer keys, the link of which is given in the description box. So with that, I'm going to conclude this second part of symbolic logic. We will continue in symbolic logic part 3, that will be the last part, and there we shall talk about common valid argument forms, common invalid argument forms, statement and statement forms, and solve some related exercises. Till then, download PDF 1, 2, 3, and 4 for practice and reference. Take care. Goodbye.